All right, class, we are now talking about enthalpy. We talked about it a little bit in class, and yeah, let's just kind of continue on from where we left off in class. So enthalpy is the idea, again, if a process takes place at constant pressure, so the idea is that when we're doing chemistry, for the most part, it's all under constant pressure. The only work done is the pressure volume work. And so we can account for the heat flow. So if we think of heat and work, um, so the heat flow during this process is what we call enthalpy. So when we measure like the heat in a reaction. So enthalpy is the internal energy plus the product of pressure and volume. So how do we kind of tease this out? So when the system changes at constant pressure, the change in enthalpy is equal to delta H. So the heat of the reaction is equal to the change in the energy and the pressure volume relationship. So we rewrite this as delta H is equal to delta E plus P times delta V. And you notice that there's not a delta P because pressure is held constant. So we have the change in heat is equal to the change in energy of the system plus the change in volume times the current pressure. So since we know that the change in energy is equal to heat plus work, and since work is equal to negative P delta V, right? Okay, so W is equal to negative P delta V, so they're related. We can substitute these in to the enthalpy reaction, okay? So we plug in for delta E into the equation. We plug in Q plus W, okay? But we know that W is equal to negative P delta V, and we've got this P delta V already in there. So basically, the work gets canceled. So enthalpy, so when we are actually calculating enthalpy, what enthalpy is equal to Q, or the heat of the reaction. So basically, the work in a constant pressure reaction, the work is it's basically canceled out algebraically in the process, and so delta H, or the enthalpy of a reaction, is equal to the heat of the reaction. So that was what I was trying to lead towards today in class, and didn't do a great job. So hopefully this kind of clarifies that bit a little bit more. So at constant pressure, the change in enthalpy is the heat gained or lost in a reaction. So delta H can be either positive or negative depending on the type of reaction. So endothermicity and endothermicity, or exothermicity. So endothermicity, or something that is endothermic, is when delta H, or the enthalpy, is positive. Okay, so it's endothermic, meaning it absorbs heat, and so therefore the delta H, or the enthalpy of the reaction, is said to be positive. So if you have an enthalpy of a reaction that is positive, it absorbs heat, it's going to be a positive number. Most likely you have to either heat the reaction for it to occur, or it might get cold in the process, or it might feel cold to the touch in the reaction vessel. And then the opposite is true for an exothermic reaction. The delta H, or the enthalpy of the reaction, is negative, meaning it has more energy. More energy is given off from the system rather than it absorbing. And so enthalpy is negative, or the heat of the reaction is negative. All right, and we will do this tomorrow. So that's it. 4 minutes. Fantastic. You may have heard a little bit of music in the background. They are prepping for the lip dub. So we'll talk to you tomorrow. Turn off.